Good evening all and welcome to class. Please let me know if you can see my screen. Let me also know if you can hear me very well.
Yes, sir.
All right, so in the last class, we were able to finish up with page layout. Don't know if anyone has any question on what we did the other day. If you were in the class, is there any question about this page layout? If not, we can jump into what we have today. We are actually going to learn about the formulas ribbon tab. But before we dive deep into formulas and by extension functions, we'll need to refresh our memories again on what we did some time ago and maybe add more new things. Because this one will be like the foundation to understanding what we are going to do with formulas. So if we are good, we can start. By way of definition, I can say that cell references in Excel, are used to refer to specific cells in the worksheet. For example, if I click right here, this cell has a name. Remember, we talked about cell name when we started this training. And I told you that every cell has a name and that name is here. Look at the name box here. And so the name of this cell is E1. Why is it E1? It is the intersection of the column header and the row header or title that gives this cell a name. So as I click this place right now, I am in column E and then row 1. If I come down here and click this place, I am in cell A17. You can see that there is 17 here. The row number is 17, while here the column header is A. So if I am referencing, if I enter values here, say 45, 56, maybe 89. If I am referencing this cell elsewhere, it could be maybe somewhere here. I can type equal to, this cell's name is D1. So if I type D1 here, you can see that immediately it highlights this very cell. So if I press enter, it brings this 45 here. That's what I just did is I just told Excel to replicate this number right here. Let what is in D1 be in I1. So that's how to reference a cell. The same thing is applicable if I am referencing this cell. I can be here, maybe in K5, right here. I can reference cell D2. If I type equal to, and if I type equal sign, and type D2, I am referencing this cell right now. Okay? And if I press enter, it brings in 56. If I want to add this, and this, right here, I can type my equal sign Sorry for that background noise. So I can type my equal sign right here and type D1, sorry, D2 plus D3 plus D4 and press enter, and it will give me the summation of these three cells right here. So what I just did here is referencing these three cells. I hope that is understood. All right. Now, absolute reference. When we talk about absolute reference, so an absolute reference by definition refers to a fixed location in the worksheet that does not change when a formula is copied to another cell. What that means is that, for example, if I have, say, day 1 here, let me enter this data. Day 1, day 2, and I have maybe a little data set here. And I want to get the summation of this and this. The same way I type my equal to, I can also click to reference this cell plus this one and press enter. It gives me the summation of these two cells, right? I can also use, let me delete this and use sum equal to sum. This cell, I can just click and drag, then close my bracket and press enter. It will still give me the same result. You can see that this sum now is called a function, right? So now, if I drag down.
Sorry, sir, your screen is not just static.
I think it's your network. Can others see my... Is it the same for others?
No, I'm saying maybe it's network on this end.
I think it's your network. All right. So now what I was trying to do is to drag down, as we learned before now. Either you double click this small square that is here. When you hover on that square, your cursor turns to black cross. You can double click it and it copies the formula down. That means it calculates this and this and give me the total, calculates the sum of this and gives me the total. So that is what we call, that one is called relative referencing, because as you drag down, it steps down to the next row and calculates. Steps down for this one, it also steps down to the next row and also calculates the total for this one. So that referencing right now is known as relative referencing. But when we talk about absolute referencing, when you make a cell absolute, right, it means it cannot change like this. It cannot change the same way this one changed. Let's say, for example, I want to multiply this total by 2. Okay? And then I have that 2 somewhere in J1. When you want to make a cell constant so that it will not change or absolute, right? So as we have this very figure right here, and you want to use it to multiply this total. If I want to multiply 103 by 2, 132 by 2, and 70 by 2, right? It means I am multiplying everything here, right, by 2. If I just type equal to 103 and then I type my asterisk that represents multiplication, and I click this very cell right now where I have my 2, it will give me the answer quite all right. But if I drag down as it is, you will see that it returns 0, 0. The reason is that Excel expects a number here and a number here, because as this formula is right now, if you look at this formula right now, it's a relative formula. As you drag it down, Excel looks for the next number to multiply with 132. If I add like 4 here, you will see that this place will change to a number, right? Because Excel was looking for a number here, but since there was none, it returned 0, okay? But if I come to this very formula now and add a $sign right here and here, you can see that it highlights these 2 here. So it makes these 2 an absolute reference. So throughout, it will not change. If I drag down now, you will see that it will give me, yes, it's supposed to give me, let me delete this. So now, sorry, I did the wrong thing here. It's supposed to be J2. J1, sorry. J and 1. Where this 2 is J1. Okay. So I have now, look, if you look at this formula, you see $J and $1 before I multiply with what I have here. Look at this, F1. So this is the correct formula right now. Okay. So what I have succeeded to do now is that I have made this 2 an absolute reference, and then I multiply it with this. So if I press enter, it gives me 206, the same result we got before. And if I drag it down, you will see that it will give me the results for all these other ones, right? And you can see that all of them are referring to these 2. That is 132 times 2, 70 times 2, because of this $sign that you have here. So this is an absolute reference. It makes these 2 static. It tells Excel, okay, as you are calculating this multiplication here, don't look for anything under these 2. I don't know if you understand me. Do you understand? So this is an absolute reference. Now, as you are entering the formula here, if you add this $sign, it means you've made that very cell an absolute reference. There are some times you may also mix the reference, as this one now, mixed references. So when we talk about mixed references, it's when you either use one of them. You can make the row static and make the column relative. So when we talk about mixed referencing, the definition is that a mixed reference is a combination of of absolute reference and relative reference, right? So either the column will be relative or the row will be relative, or the column will be fixed, the row will be relative, or the row will be fixed, the column will be relative, right? So any of them that is relative will move. Let's just move down to the operators. Of course, in Excel, we have mathematical operators, right? And we also have logical operators. Okay, so The plus is used as your normal operator, the normal mathematical operator for plus. It is used for addition. Of course, you've seen us use that many times. The minus you see here does the same thing in mathematics. It minuses, right? If I say equal to this one, or say this one minus this one, it gives me, I can drag down. That's that. Sorry. This should be equal to this one. Yeah, minus this one. Okay, minus 53. All right, so what happened here? 35 minus 35, okay, 0. All right, so it's correct. Now, we also have multiplication. We've done that one. So it's the same thing. It's the same thing. If I multiply equal to this one multiplied by this one, right? And drag it down. You can have the division also. This one divide by this one. It gives us the solution, the answer. And then the last one there is exponential or exponentiation. Like we can say 2 raised to power 2 is 4 raised to power 2, just like that. So anytime you want to do something about exponentiation, this is the caret, we call it the caret, is what you use. So I can say 25 equal to this 25 raised to power maybe 25. It could be raised to power anything. That's what it gives, right? The number is too big. Let's change it to raised to power 2, just 2, and enter. You can see 625, right? That's this raised to power 2. If I drag down, you'll now see this is 36 now, raised to power 2 gives you this, 35 gives you this, right? So that's how we use mathematical operators in Excel here. The next one is logical operators. Of course, you've seen me using that logical operator before when we type or when we say let this cell be equal to this. So if I want this cell this very cell D7 to be equal to this cell D2, I can just type my equal to and either click this place, press enter, right? Or if I want to type it by myself, I can type equal to D2, the same thing. You'll still give me the same 25, right? So greater than is also a logical operator. Now, how do we use it? If I come right here and type equal to this D2 greater than E2 and press enter, it will return false, right? The reason is because this is not greater than this. I hope you understand. Hello, are you there?
Yes, that's so, sir.
Yes, because this is not, 25 is not greater than 78. That's why it returns false. So it returns a Boolean, we call it a Boolean value, right? So if I drag down, you can see all of them are false. But if I come here and make this one, so let this one be like, okay, let me use 35. Let this one be like 38. You will see that this one will return true. Can you see it? All the calculations we did before are updated because this number has changed. That is the beauty of referencing Excel. If I use the normal manual way of adding or subtracting just these numbers, you will not see any of these ones change. Now watch the way they were. 35, this 35 here, and see 0, 0, 1, 1, 2, 2, 5, and 1, then 1, 2, 2, 5. But if I increase this number to 38 right now, all those ones will also change, and this becomes true. In the same vein, when we talk about less than, so if I type my equal sign and click 25 less than 78, it will return true. Because, of course, it is true that 25 is less than 78. So I can also drag it down. So when it comes to the last one, it's now telling me that it is false because 38 is greater than 35. Right? Okay, so let's create a little table here once again to demonstrate greater than or equal to. Let's say 23 here, 45, and maybe 56. And we have another one, 58, 35, and 26. So the same way, I can come here, type equal to, click this one, greater than or equal to. You see the two of them are in the same place. This one, it returns false, right? If I drag down, 45 is greater than. So this very operator here, this logical operator that has both greater than or equal to, or less than or equal to, is used to return this. So if I want to use a less than or equal to, I can still do the same thing. Because of that or, that is why it is giving this false, right? So this one equal to this less than or equal to this. It returns true because it takes the first one, less than. So this 23 is less than here. It's less than this 58. It returns true. We will use this in comparing values. This is just the introduction to it. You will really see how it works when we create a table that will make it clearer to you in case you don't understand. The next one is this very one, not equal to. Let's see what it does. Equals 23, and I type both greater than and both less than and greater than this, and enter. It returns true. You can see that all of them here return true. That is because 23 is not equal to 58. 45 is not equal to 35. 56 is not equal to 26. Right? So if I come here now and change this number to 26, it will return false. Can you see this? It returns false because 26 is the same as 26. I hope you understand. Hello, are we there?
Yes, sir. Yes, sir.
So these logical operators are used to compare data, right? In your journey as a potential data analyst, you may be comparing data to find out what and what are the same and are not in your data set. So there are a lot of things that can demand you to carry out all these operations. That's why I'm taking my time to explain this to us. Okay. Now, we can also do calculation across cells. It is not only on the same sheet, right, that we can do calculation. We can do calculation across sheets. You can have different data sets from different sheets, and you can still carry out your calculations from those different sheets. You must not bring them together, right? So let's talk about this. Calculation across sheets. Let's say in sheet 3, I created a table here that will help us to do that. This one is changed to table, while this one is normal data set, right? So I want to calculate the total from fan, bulb, and socket, right? I want to get the total here. So the same way we normally do, remember, we can use auto sum, right? And then highlight or select where we want to calculate and press enter. That sum is a function, right? It's a function. That's one way of doing it. Another way of doing it is that you can just select this up to this point and click your auto sum. Remember, we also have auto sum right here. Remember when we did something here? When we were learning about home ribbon tab, the ribbon groups that are in home ribbon tab. So it's the same thing here. Now I think why you have this this green rectangle here, there is an information there. So it's telling you that there is an adjacent cell that it's referring to this one right now that we did not include. All right. So it is asking, it's trying to know if it should include that cell, but we didn't want to include that cell, so we leave it like that. If I drag down, I get my totals there, right? Why this one is 120 is because it added that, so I can also remove. Let me delete this one. This is a table, right? Now I want you to look at why I changed this one to a table is for you to look at the formula, the difference. Even though they are bringing in the same, they are going to bring in the same results. Right? If you look at this formula, you can see that I use the function sum to return the sum of these three cells, right? Now, if it was a table, it would not be the same. Remember, tables also have names, right? Tables have names. So when I am calculating this, what will happen? If I highlight this and go to my formulas, I can click this, right? You see that because it is a table, right? It calculates, first of all, it calculates everything at the same time. Do you understand? It runs everything down the same time. Let me delete it. If I do this up to this point and I click auto sum, it runs everything. Remember that I only highlighted or selected only this row, but when it was calculating, it calculated for all the rows. All right, so now let me delete this and do it manually, and do it and use sum to do that. Equal to sum. Right? I want you to look at something. That's why I am doing it this way. Plus this plus this. Sorry, this is plus. That's why I didn't return anything. Now I want you to look at this formula. Can you see what's happening here? Sum is it takes the title of the table, right? With this at sign plus at sign of Bob plus at sign of socket. Can you see that? Hello? You see the difference now?
Yes.
So when you see something like this, right? Don't panic. It's still the same. It's still the same thing. Is why it is doing it this way is because what you have here is a table. Do you understand? So assuming I also used type it by myself right here. The sum equal to sum of this plus this plus this. And then close my brackets, press enter. You see the difference? This formula right now. Look at the difference. When you come here, look at this. So when you are working with a table, you'll be seeing this kind of formula. When you are working with normal data set that has not been changed to a table, you'll be seeing something like this. I hope you understand that. So we wanted to talk about calculation across sheets. Okay, so right now I have gotten my totals here, right? All right, so let me copy this and come to sheet 4 and paste. Copy this and paste sheet 4. So the same thing we have here, we also have in sheet 4, right? So if I want to say this one, assuming this one is week 2, right? Even though we still have the same data set, let's assume that this was a different data set where you calculate different things, okay? Or maybe I can leave what was there before, right? Let me leave this and calculate this. Let me do the sum of all this. Okay, like this. So I have this as week 1. This is for week 1. And this is for week 2. Let me create one row here and type. Okay, let me copy this. Let me copy and paste. right? So now calculating across sheets means that I can be in sheet 5 to get the sum of sheet 3 and sheet 4, right? For example, if I want to calculate the whole of this, right, 119 plus this 119, and get my answer here in this very place, that's sheet 5. I can do that. The same way I type equal sign, when I type equal sign, I can come to sheet 3 and click this. Now watch what is happening, the formula bar. So I can now type plus. I come to sheet 4 and click this and enter. It will give me my answer. You see it? So now watch also how Excel renders this formula here. Okay. The formula that brought in this is what you have here. So it references sheet 3 from the E3 and then sheet 4 E3, right? And if I drag down, remember it's a relative formula. It goes the same way. Since it is relative, it takes all this and all this and give me the solution here. Is that understood? That means you can calculate across sheets. Do you understand? So there are times you may want to do this. Maybe in a data set. Is that understood?
Yes, sir.
All right. Now let's talk about cell range. We can talk about cell range and cell naming range. If you look at this formula, if I use sum here, right? If I use sum equal to sum, right? And I select this place to this place, close my bracket and press enter, you will discover that there is a colon in the formula, right? So this colon is telling you that you are calculating from a range B3 to D3. All right. So instead of us doing this, instead of us doing B3 plus C3 plus D3, we use colon, right, to represent all the cells that are in between, no matter how long that data range may be. Okay, once you add this colon, you take the first cell of that row, if your calculation is in a row, and then put colon and come to the last one and take the last cell reference of the last cell you want to calculate in that row. Excel will include all the in-between cells in that row. Is that understood? We will be using this very
Yes.
well because we will be using functions. Okay, we'll be using our functions to do some data manipulations. I can just drag this down. So know that this is the same thing as this. It's a short form of this. This formula is the same as this. Is that understood?
Yes, sir. Yes.
All right. So naming of a cell is still a bit far because this is where it is. This is where we'll do it. All right. So I will skip. Let me take these two down. Let me take those two down. We'll talk about them later. All right. So now we talk about types. As a data analyst, data types are very important. We discussed it or we learned about it right here when we were learning how to use or learning about the home ribbon tab. All these are different data types. Okay, this is just to remind you of what we did some time ago. So currency is a data type, number is a data type, counting, date, short date and long date, time, percentage, and so on. All these are data types. So as a data analyst, when you are working with data, you must use the data type. The data type of a particular column has to be the same, right? So you avoid making your data type general. All these ones that we've been doing are under general, okay? Not because it is wrong, but because you want to be very sure so that if there is any problem somewhere, you will know that, of course, you were using the same data type. If your data is a date, every column, if this column is for date, every data you enter in this column, in that data set, must have date format. Do you understand?
Yes, sir.
So if it is currency, for example, if I want to change this to currency, I cannot make this one currency and make this one, and this one is maybe a text. This one is maybe a date. This one maybe percentage. And this one scientific. This one general. You see this kind of thing, right? If a given data set is like this, it means that data is datey, right? You will be the one to clean it and make sure that this column has the same data type. On no account should your column have different data types. It must be one data type. If it is date, let everything be date. If it is currency, everything must be currency. If it is number, everything must be number. this kind of mixture cannot work, right? Because it will not give you the correct representation or correct results of your data set. It will cause problem for you along the line. I hope that is understood. I'm taking my time to explain these things because we are very close to applying what we've been learning. All right. So now the next one there is functions. Now let us go to our formula. Let me just copy this table, data set, and go to sheet 6. Test it. All right. So as I have said before, hello?
Yes, sir.
All right. So the first ribbon group that we're going to learn in formula is this function library. As the name implies, the whole thing you see here are functions. Remember that what we were talking about, what we're doing before now, were all, or almost all of them were formulas, apart from the ones I use sum, right? So when we talk about functions, functions are predefined formulas, that perform specific calculation, using the data you provide them. Okay, they are already defined by Microsoft. That's why you see all of them here. While formulas are instructions you give Excel, just like those ones we did. If I type equal to this cell plus this cell plus this cell and press enter, it will give me the result, but that is a formula. Those are instructions that I just gave to Excel to calculate the total of these 1, 2, and 3 cells for me. So this is a formula, right? So, but a function is a predefined instruction or predefined formulas performing specific tasks with the data you gave to them, or you give to them with the data you give or you provide, right? So if I say equal sum, this sum that you see here is a function, right? And this sum, this function expects parameters. You can see sum, the first one, it's waiting for me to enter the parameters. Enter number 1, enter number 2, and so on. So I was trying to say that the first number, I can use cell reference to represent that number, which is 1. And then I enter my comma. Second number, you can see it moves to second number now. This is the second parameter. I can click 53. The moment I type my comma, it moves to the next one. And I click 10, which is C2, right? When I'm done with all the cells I want to click, I can now close my bracket. That means I'm done. So when I press enter, it returns this total here. Do you understand? So this sum now is called a function because it is predefined, right? So formulas are written to these names to perform what these names are for, or what this name is for. So all these, the names and the functions that we'll see here, formulas are written into them, all right? Predefined formulas are written into them to perform. So when you call this function, it performs what you want it to perform. So that's the difference between formulas and functions. Formulas are instructions that you give to Excel to perform a particular task or calculation, while functions are predefined formulas by Microsoft to perform specific tasks using the data you give to them or you give to it, right? So now, right here, we have the big 5 formulas. Remember in Home tab, we learned about them. Look at them. Sum, average, count, numbers, and maximum and minimum. Okay, so back to formulas. If I click insert function, you can see that we have a lot of them here. Okay, most used formulas, you can see the sum, see average, see the maximum, and so on. These ones are my most used, most recently used formulas. I use them to do something, right? So when you come to this dialog box, we have a lot of them. If you click and drop down here and click all, there are so many of them. Mathematical formulas, so formula for financial people, logical formulas, text formulas, and so on and so forth, right? So we will learn some of them. So the same sum I typed, if I click here, I can also find it right here. Just that I will have to scroll down. To ACE, RS, look for it here. Look at sum, where it is, right? So if you know these functions, if you know the name, you don't need to come here and start scrolling, right? It's just for you to type. So now let's do sum here. And let's do average here. Count. Then we do what again? Minimum and maximum. So this one, I can type my equal to sum. This sum, we've used it too much, so by now you should know how it works. And I come here and double click this small square here. It returns all of them. Average, right? The formula for average is the count, the sum of the range divided by the count, right? So equal average, press tab, and then divide by 3. The count is 3. 1, 2, and 3. I hope you understand. So that is what Excel will use to calculate the average of this. So I just added that slash, this slash and 3 to show you that the count is 3, but it is not needed here, right? So if I press enter, you can see the average of these 3 numbers. You use your calculator and press the average of this plus this plus this. Divide by 3, you will have this. I can double click, thumbs up. Count returns a a single value. So the count of this, please remember, when you type a function's name, count, like count, right? You will see it here. It is either you double click it or you press tab, right? Once you press tab, it will open a bracket waiting for your parameters. So count of 1, 2, 3 should return 3. Make sure you close your bracket. The reason is that we have 1, 2, and 3. So that's all of them will return the same 3, because they are 3, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on, right? So if we want to check the minimum between these 3 numbers, it's the same thing, equal to min, press tab, I select the range and press enter. So 10 is the minimum. If you check 56, 53, 10 is the smallest number. That's why it returns 10 here for me. Okay, the maximum number, the same way, equal to max. Press tab, select your range, and enter. 56 is the highest number there. That's what it returns right here. So now we have just used functions. Okay, we just use functions to get what we wanted here. So those are functions. And what we've done here are the ones you see here. 1, 2, 3, 4, 5. When you click more, if you click more here, it takes us back to this dialog box, function dialog box. All right. The next one is recently used. Just as the name implies, all these ones were recently used. That's why you see them here. I hope you understand. This is just the last one that I used. This is the last, this is the second to the last one. These are the ones we've used. Maximum, you see it's sum, average, all of them are here. All right. So back to this place. We've talked about functions. All the ones that you have here are functions for financial institutions. They understand what these ones are used for. Maybe later we'll use a few of them, because in the journey of data analytics, you can be a financial analyst. You can be a business intelligence analyst. So there are different specializations, right? So those who are in finance will use mostly these functions that you have here. So now let's look at logical functions. That's why you have all these ones. Logical functions. Let me open a file. So when we come next, we will, or later in this training, we will talk about naming range of cells and talk about errors. Or these errors, you see them in Excel when things are not done right. So we'll talk about these errors and talk about how to how to handle them properly. Are we still there?
Yes, sir. We are here with you. Yes, sir.
All right. So, how many of us have heard about or know about truth table?
Sir, I heard when did you do digital electronics?
Oh,
Level 100.
all right. All right. So, now let's look at this logical function. And is a function, but it is called logical because it is used to make sure that two things remain the same before it can return true. Right? So now let's look at this data set right now. We have A here. It has 15 and 8, then B 10 and 28. Now the condition that we have to give, we need for this to return true or false is A is greater than 10 and B is greater than 5. If these two conditions are met, it will return the result, expected result will be true. Let me delete this. Right? The expected result, and maybe change this to this way and this to this way. All right. So this is the expected result it's supposed to return. So if actually A is greater than 10 and B is greater than 5, it should return true when we enter the formula. And how do we enter this formula? That logical and will come first. You can see it, press enter. You click your cell reference greater than what? 10. I'm looking at this condition, right? Comma. You can see the first logical parameter is entered now. Second, you can enter as many as, right? Second logical parameter will be this B2 greater than 5. If this is true, it will return true. You can see this. Look at the formula that returns true. Is that understood? We use it to make sure that
Yes, sir.
a particular condition is true. The same way, if I don't want to drag down, this one will return false, right? The same way, equal sign, you type your and, open your bracket. This is greater than 10. Is it greater than 10? Is 8 greater than 10?
No, sir.
It's not greater than 10. And is 20 greater than 5?
Yes, sir.
It is, right? So it returns false because when you are using and, the two conditions must be true before it can return true. Do you understand? But if we are using
Yes, sir.
or, this or that we have here, let me enlarge this. Look at the condition. The same way, right? It will or will return true if one of those conditions is true. Do you understand? So if I say, look at the condition now that I'm giving. If A is greater than 10 or B is less than 5, if any one of those conditions is true, the result will be true. If both of them are true, the result will still be what? True. Do you understand? So if equal to or, A is greater than, that's A2 now is greater than 10, comma, then B2 is less than 5. If any of the conditions or both of them are met, it will return true. Can you see that? It returns true. These logical operators or logical functions are very, very important because you'll be using them very, very well. Right? Now, let's check the condition for this one, the second one. Equal to or. Remember, it is the logical name, is the logical function name that comes first. If this is greater than 10 or this is less than 5, you see it? So 5 is not greater than 10 and 20 is not less than 5. You can see that both conditions did not meet this condition. That's why it returned false. If I change this 5 now to 11, it will return, this result here will change to true because one of those conditions is met, and that is how OR works. Let me take it back to 5. Do you understand? So if this is 15 or maybe 12 and this is 2, it will still return true. See that? So when we are talking about OR, one of those conditions, once it meets one of the conditions, it will return true. Is that understood?
Yes, sir. Yes, sir.
All right. Our time is fast spent. Let me just do one more. Then we'll continue in our next class. The not. Now, not is used to negate a particular condition. So for example, I have this right now. The condition is that the condition I want to use or I use for this false to return this false is that A2. So this is A2 which is this place now, right? This one should be A3. So now, if as I enter this formula now equal to naught, A2 is greater than 10. Okay, please, this 10 is not just 10. No, it could be any number, right? So is 15 greater than 10? The answer is yes. But because of this not cancels that yes, and that's why it will make it false. Do you understand what not does now?
Yes, sir.
The answer is correct, but because we have this not, it negates it, it turns it the other way around. Next one is 5 is greater than 10. Let me change this 10. Let it be any other number. Say 12. Is it true that 5 is greater than 12? It is false, right?
5 is not greater.
5 is not greater than 12. But because of this not, it will return true. Do you understand what it... Okay, go ahead.
Can we call this negation? Can we use another name like inverse?
Yes, of course. Anyone that can make you to understand an inverse of the real thing, right? That's the other side, the opposite. Can be the opposite or whatever you want to call it.
So the opposite of the answer we got is supposed
Yes.
to be true because of
It's supposed to be true, but because of this logical function here, this not, it changes it the other way around.
Okay, sir. Thank you, sir.
Yes. So that's how it works. The same thing is applicable here in this reverse logical values. So we have true here, we have false here. If I come to my formula and say not A2, this is, okay, let me use not A10. Not A10. I want to look at this very value now. So this should be A10. And press my enter. It returns false because of this not. Remember that this is A10, but not brings it to false. Is that understood? So the same way, this very one, this is A11. Not using A3 refers to this one. So A11, this is A11. But because of this not, instead of it to return false, it will return true. This is false, right? In A11. So the inverse of it, as you said, is true. This is true. The inverse of it is what? False. The opposite. So this not takes the opposite value of the logic or logical formula. Is that understood?
Yes, sir. Yes, very. I understand, sir.